Good morning, everyone. Yes, sorry, I'm on mute. Good morning, everyone, and welcome to this webinar for the launch of a new Vertex family of Trina Solar. I'm Aurélie Beauvais, the Deputy CEO of Solar Power Europe, which is the European Association of the solar sector. We have today more than 250 companies which are active in Europe, and it is a pleasure to present today this launch with Trina Solar, which is one of our key members. Before we start introducing the new family of big size modules of Trina Solar, I would like to have with you a short time for housekeeping rules. So this webinar will be recorded and you will receive a link after the event, no worries on this side. And you will not have the possibility at this point in time to open your microphone. Sorry, everyone is muted. However, if you have any question at any point in time, feel free to write it directly in the Q&A channel. And the Trina team, which is here behind the scenes, will make sure either to answer you directly or to answer your questions after the event in any case. So today we are absolutely delighted to welcome speakers from Trina Solar, TÜV Rheinland, and DNV in order to introduce to you the latest solar PV module portfolio, and in particular also looking at ultra high power, as well as the challenges and opportunities of using big modules and looking at how Trina Solar, but also the rest of the solar industry are working and innovating, not only to overcome these challenges, but also to bring forward or even further lower LCOEs, which support the competitiveness of the solar industry and contribute to making it the true king of electricity, if I may quote the Director General of IEA, Fatih Birol. So before we talk about technology and innovation, we wanted to start with a little overview of the market. And it is my pleasure to introduce to you very quickly some key insights on two of the latest studies that were published by Solar Power Europe, our European Market Outlook, and our 2050 study. What you have here is let's say the screenshot of the growth of the solar PV industry in Europe between 2000 and 2020 with a focus on this year. And I have to say that even at Solar Power Europe, we have been extremely surprised by the resilience of our sector and the growth of the solar industry, despite a year which has been marked by COVID-19 supplies shortages all across the economy. And yet the year 2020 was the best year for the solar sector since 2011. So it had been almost 10 years that we didn't get such a big annual growth in terms of installed capacity. That is a very positive signal, which follows an even more exponential growth in 2019, where we observed a growth above 100%. What we see is that this growth is likely to materialize also in the next 4 years and with even more ambitions. If we look at the next years before 2024, we anticipate double-digit growth almost every year, with yearly installations that could even exceed the 30 gigawatt level already in 2023. So we are really looking at exponential growth. It is, on the other hand, absolutely necessary to make sure that the EU can meet its energy and climate objectives, and in particular, the European Green Deal, which has been announced as Europe's flagship policy proposal to fight the climate change. And here, I would just like to share with you one little insight of our 2050 study, which was released in May 2020. And where we wanted to model what it would mean for Europe to achieve climate neutrality with a scenario that is a 100% renewable scenario. And what you can see is that solar energy really drives the bulk of this transition. And by 2050 could actually procure more than 60% of Europe's electricity generation. To achieve this, we will absolutely need utility-scale solar installations, which will enable not only to drive the volumes, but also to drive the cost efficiency of this transition to the benefit of European citizens. This is why I'm very happy to be there and to have the opportunity not only to moderate, but to listen to our speakers, which will be taking the floor in a few seconds. And I will then gladly hand over the floor to Gonzalo de la Viña, which is head of module business Europe for Trina Solar. And I will just unshare my presentation, Gonzalo, and let you share yours.
Thank you, Aurélie. So good morning to everybody. This is Gonzalo Laviña. I'm the head of Europe for Trina Solar. And I'm pleased to participate today in the launch of the Vertex module, which I think will help us to even improve the situation and the numbers we had in 2011 in Europe and globally. So I want to give you a quick update on Trina. I'm pretty sure that almost everybody on the call knows us. So there's not much that can surprise you. Just this slide just gives you an overview of where Trina is. I mean, it's a truly global company, as you can see. We're in every country, in every region, you can say, of course, headquarters in China. And then from Singapore, we manage APAC, from Dubai, Middle East and Africa. And from Switzerland, it's our headquarters for Europe. And on the next slide, I will go a little bit further and into details for Europe. From San Jose, we manage North America, and from Miami, South America. More interesting, though, is what we have achieved and accomplished till today. We had deliveries of more than 66 gigawatts till 2020. Just in 2020, we delivered 15 gigawatts, and this year we plan to double this number. As I said before, this is the picture how it looks like in Europe. You can see that we have a very, very strong presence in Europe. We have over 9 regional offices, being the main ones, Zurich, Munich, and Madrid. We have more than 100 employees. Here we also count, of course, our colleagues from the tracker business, from the storage business. And we're active in more than 20 countries in Europe. What's also important to me is to understand and to convey the message that Trina is not only a module maker. Everybody knows Trina for the last 22 years for being an excellent module manufacturer and supplier. This is true, and this will for sure not change over the next 20 years and hopefully more. But we are also a manufacturer of Trina of trackers. And we acquired a tracker manufacturer in Europe already in 2018. Last year, we took over 100% of this tracker manufacturer, and this is why we were able to change the name and the brand to Trina Tracker. On the other side, we also do utility projects. This means we build them also and connect them, and then we sell them. This is what we do outside of China, and quite successful, especially in LATAM and South America, but also in Asia and starting in Europe. And what's also very important is that we are also a supplier, but not only supplier, we also develop and manufacture storage systems for utility applications. So this is something that has started just 2 years ago, and now we're delivering the first systems into Europe. So this is why I'm saying that for me it's very important to, again, define the Trina as module, its projects, its tracker, and it's also storage system. So don't think only as a module supplier when you talk about or think about us. On the next slide, this is something we're very proud of because we are ranked as the most bankable module supplier by Bloomberg. This has been awarded to us for the 5th year in a row. And you can see below our competitors. So this is something that we're very proud of because it shows that the banks rely 100% on Trina. But this is not only about business and about revenues and shipments. We also have to think about our heritage where all of this started, and we're very much focused on sustainability. On the left side, you see what we have been able to do in the consumption of water and electricity over 4 years. So from 2014 to 2018, we have been able to reduce the water usage in manufacturing by 32% and the usage of electricity by 39%. And of course, we're working since 2018 even further to reduce this further. And the result of it was that we were able to reduce the greenhouse gas emissions by 35%. All these actions and activities that we have been doing to become more environmentally friendly in our manufacturing has been recognized by companies like EcoVadis, where we have the gold recognition level, and also by the Silicon Valley Toxics Coalition. Last but not least, we're here today, as I said before, to increase even the shipments and to beat the market in Europe from 2011. And we're here to discuss today and present to you guys the new 210 millimeter module. So in order to be able to manufacture and deliver what we promised to the market, we've expanded our capacities considerably. So we have opened factories in Suqian, in Yangcheng, Zhangzhou, where our headquarters is, and in Yiwu. All in all, by the end of this year, our capacity will be 50 gigawatts on the module side and 35 gigawatts on the cell side. So this is doubling the capacity. I'm pretty sure that most of you have already read in the news the efforts that we're doing. We're investing more than $3 billion over the next 18 months to increase our capacity. And this is also what is being reflected here. I mean, we need this capacity to also cover the demand that we expect over the next year. Aurélie already showed you that the next years in Europe are very promising, and we expect the same also from other regions in the world. When you look at the blue column, which is 2019, and the red one, 2020, you see that our shipments have increased by almost 60% globally. When you look on the right side, it's the same for Europe, just for our region, for Trina. And in blue, you see that we delivered in 2019 2.1 gigawatts into Europe, and last year, 2020, almost 3.4, which is a growth of the same, almost 60%. And again, just as we plan to double our capacity this year in 2021, we also plan to double our shipments into Europe for 2021. So we are prepared for 2021. We are prepared also for the launch of the 210 millimeter module. We're seeing a very strong demand in the market. Everybody, every partner, and even people we're not working on, they're approaching us, asking us specifically for this module. And now I'm sure that the requests to get more information on the new DE21, the 670 watt module, will increase now after today very strongly. We are prepared because we've signed many agreements, many long-term commitments, many joint ventures upstream, and we also are expanding our own capacity. So the modules and the quantities that we will sell will come. Also, we are diversifying, as I showed before. Trina is not only a module maker, we also manufacture trackers, we all manufacture storage, and we do systems. So all in all, we are a very strong company, very diversified company, and all these products like modules, trackers, and storage will become more and more important to Trina. Last but not least, we're one of the founding members of the 600 watt plus alliance, where we have different manufacturers, not only from module side, because as you know, many of other module makers are also doing 210 millimeter modules, just as we're doing, but also from the inverter side. Companies like SMA, like Sungrow, like Huawei, they are also participating and supporting this strategy and this product. And the same also for the tracker. It's not only Trina Tracker manufacturing it, but you have Next Tracker and others going in the same direction and preparing their products for our module. So we are prepared for it. We're prepared for this launch. And I'm sure that you will see shortly how strong this demand is going to grow for this module. Thank you very much from my side.
Thank you very much, Gonzalo. Very exciting, and congratulations. I retain as well the two insights on sustainability and diversification across the value chain, which are also, well, two values that we see, at least in European level, are also gaining very strong traction. So definitely interesting, but it's not over yet with the interesting insights, as big size modules do gain popularity, and as you said, Gonzalo, very rightfully, we will need them to also meet the very high volumes of demand that we see here in Europe. And they're almost becoming indeed the mainstream products since 2020, which is why I'm also very happy to welcome Dr. Eckhard Janknecht from TUV Rhineland, which will share with us also technical insights on the reliability challenge potentially of big size solar modules, and the new tests that could need to be done in this regard. So Eckhard, the floor is yours, and please feel free to share your presentation right now.
All right, thank you very much for your kind introduction. Let me start my presentation.
Perfect, we can see it now.
All right. Good. My presentation. At first, to my person, I'm Eckhard Janknecht, and I'm project manager at TÜV Rheinland for PV module qualifications and certifications for 14 years now. And in my presentation, I will show some trends in the history towards larger modules, and I will also focus or highlight some of the challenges in terms of quality and reliability implicated by this trend toward larger modules. Let's start with this picture from the Jet Propulsion Laboratory. It shows modules from the very early beginnings of photovoltaics from the 1970s. Here you can see that early modules started with about 5 watt only, up to 90 watt, and you can see that the dimension of the module, of the long side of the module, was not pretty much more than 1 meter only. But already in these early times of photovoltaics, one could see already the trend towards larger modules, bringing the costs down. If we jump then into the last decade, from 2010 to 2020, we can see a further interesting development concerning the dimensions of PV modules. Here is the length in blue and the width of a module in green, and the area of a module in yellow, plotted over the time 2020 up to 2010 up to 2020. And before 2010, the situation was more or less that we had 60 cell modules with a dimension of 156 times 156 millimeter, or 72 cell modules with a little bit smaller cells. And then in 2010, the industry started to manufacture this bigger size modules, 156 in square, for 72 cell modules. And this was more or less the constant situation for over 7 years. But then in 2017, the industry started to increase the cell size to 158.75 in square. And there was a second trend to produce more and more half-cut cells, doubling the size of the number of cells in a module. And both trends further increased the module area. And this tendency is still visible in the recent years, where we even have larger cells and more cells per module. So the tendency is in general, or on average, towards larger modules. And which quality aspects do we have to consider here? Over the whole value-added chain, there are different categories where larger modules play a different role, or where we have to see what issues we have. Due to limited time, I will only highlight on these 3 categories in the red box: the module design, the component design, and the reliability of modules. Let's start with the module design. In terms of size, of course, we have to see what are the challenges. This electrical circuit design, the distances between cells, the number of cells per bypass diodes. These are different categories. Regarding the size, what is the challenge? We have the global valid standards IEC 61215, which is testing the performance of modules, and the IEC 61730 focusing on the safety of PV modules. And for both, there is a so-called retesting norm applicable, the ICTS 62915, which tests or which defines which tests have to be repeated in case the design is changing, in case the bill of materials of a module is changing. And the categories which are interesting for larger modules are those ones, of course, the module size itself. If the module is significantly increasing, that means if we have an increase bigger than 20% in length, width, or area, the manufacturer has to repeat important environmental chamber tests like the thermal cycling and the DMP test, but also important mechanical tests like the static mechanical load test, maybe the hail test and the module breakage test. Together with the module size, also the solar cell may change depending on the specific situation. Also, different tests need to be repeated. Very important, the electrical parameters will typically increase, power, current, voltage, but also the overcurrent protection rating. And also for these increased output parameters and electrical parameters, some of the tests may need to be repeated. And also the possibly changed electrical circuitry or the distance between the cells may trigger some of the tests of these global standards. Let's have a deeper look into the effect of the solar cell size and the PV module size on the performance parameters. If we have more cells in a module, and if you have larger cells, larger cell size, both will increase the performance parameters, of course. I think this is in general quite clear. Short circuit current, open circuit voltage, and the power, the output power will increase. Also, the distances between cells may get smaller. This is a method often used to maximize the active area of solar cells in a module in order to increase the efficiency of a module and in order to reduce the total module area. So new module concepts, for example, like tiling or shingled cells, apply this method for general construction. There are limits, of course. If the cells are too close together, short circuits may occur. But there's also another problem. The smaller the distance between cells, the more critical are thermomechanical stresses which may occur in the module between neighbored cells. Higher string power, higher power in a cell string will also increase the stress that one solar cell receives under reverse bias conditions. For example, a typical example is if one cell in a string is shaded, this cell will occur a high power defined by the rest of the cells in the string and their cell power. So high power will impact this single cell in shading conditions. This may lead to a high temperature and cause serious failures such as hotspots, leading to burn marks, bubbles here on the backsheet of a module, and in worst case, even burned cells after prolonged exposure to hotspot test can occur. On the mechanical side, there is important test to test the mechanical resistivity of a PV module is the static mechanical load test. Here with a typical test assembly with suction cups applying a tensile and pressure load of typically 2400 Pascal in both directions. And this test is considered to be more critical the larger the module is. Large module sizes may lead to serious deformations of the glass, of the frame, as we can see here in this example, where a module failed this test because of a bending of the frame, of the short frame size, of the short frame side. In particular for bifacial modules, there's a problem that on the rear side, some components like the frame or the junction box may shade parts of the active area. This is of course not desired because this can cause a current mismatch between different strings and cells, which is then reflected in the typical jump in the IV curve in the ISC region, which is at the end reducing the output power of the module.
Sorry, Eka, just to tell you, yeah, you have 4 minutes to cover the 2 other points.
Yes. On the component side, I will just briefly explain which components typically can make some problems here. A module consists of cable connectors, junction boxes with bypass diodes, and higher currents means also that these components need to be rated for this higher current. Otherwise, they are not suitable for a usage here. If we in particular look at the bypass diode, current in reverse direction may have an impact on the diode performance or on the diode reliability. Large currents increase the risk of a diode failure. Here we can see an infrared image of a reverse current test where a current in reverse direction is sent through the module, in this example of about 34 ampere with 62 volts. And this causes a maximum temperature of about 92 degrees Celsius, which led in this example to a failure of the diode, which was burned. And so attention needs to be paid to the diode performance at these high temperatures caused by higher reverse current. On the side of the reliability of modules, it's very important, of course, to focus on the IEC 61215, which has occurred in a new version this year, just a few weeks ago, and on the safety norm IEC 61730. These norms are applicable for all PV modules, and so also large modules need to be able to pass these standards and all the tests in these standards. The new IEC 61215 version also addresses bifacial modules, which often are used as a concept in large modules. And there are more standards which should be mentioned here for special environments. For example, like this IEC norm, which addresses high temperatures, for example, a typical desert climate. And for non-uniform snow loads, there is another IEC standards, which is also interesting for large-scale modules. So in order to conclude, the main aspects we have to consider for large-size modules, PV module sizes have substantially increased recently. We saw that in the history of the size of modules. In particular, this means due to a lack of long-time experience, we have to perform more reliability tests, and more technical evaluation is required in order to prove the quality and the long-term reliability of large-scale modules. In particularly, tests which challenge the endurance of larger modules to increase thermomechanical fatigue may be critical here in order to assess the reliability. And large-sized modules require more reliable PV components like junction boxes, cables, connectors, also the encapsulation package and electrical circuitry. This needs to be taken into the consideration here. Yeah, thank you for attention.
Thank you very much, Eka. Perfect timing and very interesting presentation. Was really interesting insights also at the very beginning to see how the search for new model sizes to some extent has flattened for a certain period in the last decade, and with now a kind of a new gold rush for bigger sizes in the 2 past years, which is definitely enlightening in the current topic of this webinar, as well as the importance of the work that you are doing actually at TUV to also improve the reliability of those components and models years after years. So congrats for that. And the challenges which you actually highlighted in a very encompassing way are also very important drivers, if not key drivers for innovation. So that's a perfect transition as well to our next speaker, which is Klaus Hofmeister from Trina Solar, Product Marketing Manager at Trina Solar Europe. So you will now share some thoughts with us actually on how Trina Solar has worked and innovated to overcome some of these challenges in your new product lines, bringing more value to solar assets while pushing even further the competitiveness of solar plants. So Klaus, the floor is yours.
Thank you very much, Aurélie, and welcome and good morning also from my side. My name is Klaus Hofmeister, and I am part of the European Trina Solar team here based here in Munich. I would like to, let's say, introduce you today the new Vertex 670 watt module, but I will also focus on the Vertex technology itself. Thank you very much also to the product marketing team in the background who really made this possible today, that we have this presentation of the new exciting product within the Trina Vertex team. I will dive into the various topics of this new product. Let me see. Here we go. Sorry. The Vertex family up to 670 watt. I will tackle the key bullet points of all the modules we have now developed within the Vertex series. First of all, of course, the ultra high power. So we have a really big range of power, of different module powers we can supply. We talked about high efficiency, but also related high reliability. This was from my predecessor from TÜV. The focus on reliability for larger scale and high power modules is pretty high. So we have done our best to ensure reliability on the module side. And then, of course, because this new high power concept has a few technical challenges to cover, the full system compatibility needs to be ensured with all the components used in system design. So I also want to tackle this topic during this presentation. So here we have a glimpse of what's going on in the industry, and you can see from 2009 until now 2021 where we are in terms of module power. We started a long time ago below 300 watt for mono PERC modules, and today we can say we achieved a new peak with 670 watt and the 210 millimeter Vertex module design. In between, we had a lot of technological, let's say, developments. PERC was one big driver, the different cell sizes, the cell interconnect technology, all those kind of new invented and innovative technologies brought up the module power. We also have to say the modules are growing in size. So this is another challenge, not only from a technology point of view, but also from a manufacturing point of view. So today we can announce a 670 watt module based on the Vertex technology, and the 700 watt might be around already. So stay tuned. Where does the 210 millimeter cell technology come from? Actually, it's a kind of, let's say, it's an evolution of the semiconductor industry. The 12-inch round wafer, which is used in the semiconductor industry, was the foundation for the 210 millimeter full square size solar cell. And there we are today. It's considered the biggest solar cell at the moment in the industry available, with new state-of-the-art manufacturing technology in the background to be used. And I think, and we all feel within Trina, that this will guide us into the future of PV within the next 5 to 10 years. Also on the right side, when I look at this information chart, which technologies will dominate the industry within the next years. And when I look at it, and you can see the light blue color of 210 millimeter, it will dominate in the next year. So 210 is the most economical and technology platform which we can think of in the next years. And we will definitely, let's say, rule the market with all the products which are coming or which are already in the market available. And here it is. Here is the team, the Trina Vertex family, starting from the 405 to 410 watt residential product, the Vertex S, going up to the 500 watt module for CNI, and then all the utility scale products with 550 watt, 600, and the new one with 670 watt. So you can see here this big range of products for all the different segments. So the customer has a big choice here to choose the product he really needs for its specific application, which makes most sense in terms of economy. And that is the great option we can offer right now. All those products are manufactured on state-of-the-art manufacturing plants, so all built up new. So the customer is really getting the best he can buy for the money right now. What I would like to say, and what I can see here, this is the industry level on the very bottom. This is what we are fighting with. This is what our competition is doing right now. So Trina is really positioned very well overall. What you can see here on this Vertex team is glass backsheet modules. So from all the utility scale modules, the last three here, we obviously also have bifacial dual glass products available. So this, let's say, enhances the product portfolio so that the customer for his application can choose the best module which is available right now. Here's some key facts about the new 670 ultra high power module. Dimensions listed here, 2.4 by 1.3 meters roundabout with just below 34 kilo of weight, high efficiency of 21.6%. And here, the electrical data for all the engineers out there, we have a real good concept from our perspective. It's low voltage, high current. Yes, you might see, let's say the high current could be an issue, but I will come to that and I'll explain you why we don't see the high current as a risk. We see it as a chance for the future. We see it gives you a new, let's say, opportunities to do a proper system design with this module generation. So please take the opportunity to look into from an engineering point of view, and I think you will get to a very good system design. What have we introduced into in terms of innovations and technology drivers into the Vertex family and the Vertex modules? All the Vertex modules are equipped with this technology drivers. So we have the multi-bus bar round wire cell interconnect technology, which really enhances this capture of light. It really enhances the, let's say, electrical conductivity. We have a better thermal performance of the module, and we can bring the power which is generated in the cell better out of the module with the multi-bus bar technology. So a lot of drivers to bring efficiency and power of the module up with all this technology. Then we have the new cell interconnect technology, the middle upper picture, the high density module technology. This is the cell interconnect technology, which is used on the Vertex series for all our products. We are very confident that we at the moment with this technology have the most reliable one for the future. We look into the overlapping technology, but still consider it a little bit risky in terms of long-term reliability for the modules. So the high density one is the best balance for us in terms of efficiency, but also module yield and module area usage. Then with the new large cells, we also invented a new, let's say, cell cutting technology. Without it's necessary to ensure long-term reliability of the cutted pieces of the cell. So therefore, we are going away from the traditional cell cutting process with the laser melting from the backside. We invented the non-destructive cutting, which gives us a really smooth cutting edge, which definitely is improvement in terms of mechanical performance overall, and therefore increasing long-term reliability. The effect that there might be any mechanical damage induced during the cutting is reduced to a minimum. So customers can really be, let's say, convinced that this module and this cutting technology will increase the long-term reliability of the product overall. Nevertheless, we are doing also a lot of extensive reliability testing, going much further beyond the standards for all the components which are used in this module assembly. We are testing for 2 or 3 times IC standard requirements with all the module generations we are inventing right now based on the large cell technology. Although the junction box, which was already highlighted by TÜV, is one of the components which needs to undergo severe testing, we have adapted our junction box design to this high current design. So we have junction boxes with current ratings of 25 to 30 amps, depending if it's monofacial or bifacial design. We have a new bypass diode for increased safety and reliability, adapted also to this high current flow, which was also mentioned during the TÜV presentation. We have enhanced the heat dissipation capability of the junction box in order to make sure that the temperatures in the junction box are well under control to ensure reliability of the diode. So a lower junction box temperature means longer lifetime of the product and of the diode. And the bottom right temperature, let's say, diagram can show it. You have a comparison here between the junction temperatures in the diodes of 166 modules, state-of-the-art products, which are all available right now, versus the 210 monofacial and bifacial. And you can see the temperatures are in a quite similar range. So we can ensure with that junction box reliability is still in a reasonable and acceptable range to be controlled. Then the other topic, which also comes up quite often, hotspot prevention or the hotspot topic. Yeah, when I look at the Vertex series and the 210 millimeter module design, we can see that we have within the module halves a short circuit current of just above 9 amp, while we had in the past with the 156 full cell module short circuit currents within the module of almost 10 amps. So what I can derive from this is that the Vertex design intrinsically in the module does not show any higher risk than we had in the past generations of modules. So we can ensure that hotspots are well controlled. We also have new quality controls and productions to screen cells before we laminate it into the module. So a lot of, let's say, safety measures are taken to make sure that the new module designs are safe and reliable in operation, and they don't create any further, let's say, challenge or risk for the design of the system. On the mechanical side, we also invested some time and some innovation in order to optimize the module size and the frame to it. The modules are getting bigger. It is obviously the trend in the industry right now. But let's say we don't want to compromise on the mechanical parameters of the module when it comes to the mounting options. Therefore, we developed a new frame concept, which you can see here on the right side for the Vertex series. That's not only for the 670 watt Vertex, but also for the other product in the family. We have a new frame profile, which you can see here. The cross section is slightly different. The holo chamber profile has changed quite dramatically. We are using a new strengthened aluminum alloy to reinforce the frame itself by the material. We have support bars on the back side, especially for the big 600 and 670 watt module, to really cope with the loads the module is seeing. And we have, let's say, an excellent loading performance already proven by the diverse certification tests, mechanical load tests. So this new module concept is mature, it is tested, and we can ensure that we can stick to what we commit here, the loads which are given here, and also, let's say, for the different mounting options, we will provide enough loading capacity on the new module generation. System design, that's another key topic. Yeah, so we know that we have a new concept with the low voltage, high current design of the 210 millimeter Vertex utility scale generation. So what needs to be done in order to, let's say, fit this module types into the existing system designs? When you're using central inverters, I think the changes are very, very limited. Of course, you need to change the fuse design maybe and the combiner boxes, but rather than that, there's nothing else to consider besides the fact that you can make longer strings with more power per string, and that's it. And then you can connect it still to the central inverter. On the string inverter side, it is a little bit different, but nevertheless, even here, technical solutions are already available or will come soon. So you can see here some of the, let's say, most important string inverter manufacturers which are available in the market. Others are not named here, but also, let's say, everybody, or there are a lot of them, offering solutions already with existing inverters. And that's where I want to really, let's say, drive the focus to the engineering guys who are listening today. Even if we don't have optimized inverters for the high current modules yet, the existing inverter generations of some of the companies listed here, they can handle our modules. They can handle it also in a decent manner, meaning without, let's say, losing too much on the system design side, especially on the DC side. So I can only motivate all the engineering guys here. Please look into that also with existing generations. And end of Q2, we will see the first optimized inverters coming into the market for the high current module generation. So I can only motivate you. Please look into the system design, check it out, talk to us if needed, and we can help you out to make sure, okay, already now you can offer a solution with a new 210 millimeter Vertex products. Also on the tracker side, we are working a lot with all the manufacturers here and also with our own tracker to be compatible due to the new module dimensions and the longer strings we can achieve. So all the, let's say, listed names here, they are working on new products and new tracker designs to fit to our module designs. So this makes the best use out of the modules, the capability of going for long strings, and therefore driving the cost down on the overall system level. And that means also we are driving down LCOE. And that's the key focus of the new Vertex series. We want to drive down on the long term the LCOE and the costs to make PV even more compatible and to beat all the other, let's say, climate changing technologies, which we have to reduce the carbon exhaust, and that means PV is one real contributor to it. Then a lot of the discussions are going about cable losses because of the high current. I mean, we cannot change the physics of it. Higher current means higher cable losses, but we have one advantage where we can really say, okay, there is a difference. Yeah, of course the higher current will increase the cable losses, but due to the fact that we are using longer strings and we need less strings for the same DC power to be installed, we can also reduce the usage of cables. So the length, which is listed here in this formula for the cable loss calculation, will be reduced, and therefore we can somehow compensate the electrical loss due to the higher current. Here on the bottom right, there is a calculation done with different cablings for a project in Spain and Europe. So we can save, due to the fact that we utilize or use less cable in a 210 millimeter module system design, we can save on a 25-year lifetime some money on the capex on the cables. When we take into account the additional DC losses which might come from the higher current in the cables, we still have overall net savings with the 210 millimeter module system design of around that numbers which you can see here on a 25 years lifetime. So even if our competition is always saying, hey, you have to consider cable losses, we are using less cable in our systems because we have less strings to connect to the inverter, but more power per string. So please look into that. This makes your calculation probably even more positive when you go onto the system level. Coming almost to the end of this presentation, here is the team which is supporting all of our customers within the different regions and parts of Europe. Here you have the central contract address for the European Trina Solar team. When you're really interested in our Vertex, when you want to get let's say more information on the products, when you want to get an offer from our sales team, please feel free to contact us centrally and we will guide you to the right colleague to get in touch with you. We'll provide you all the information and support you in your planning phase and your sales phase of your project. That's it. Thank you very much from my side. Thanks for listening to this Vertex presentation. Thanks to the team who organized this event, and I'm looking forward for a lot of customer interest into our new product.
Thank you very much, Klaus. Very, very impressive presentation indeed, and features. Congratulations on the innovation. Very interesting to see the elements related to efficiency and the optimization of various system components. And personally, quite interested also to see the features about interoperability and compatibility between diverse stakeholders. That was very insightful. Now, to close this very interesting webinar so far, we also wanted to propose a deep dive into what it meant actually to look for bigger size models when we talk about also LCOE, and what does it mean for the competitiveness of our technology, which, and I think Klaus said that again, we would like also to see emerging amongst all other renewable solutions. So that's now my pleasure for the final presentation to hand over the floor to Mr. Chen Zhang, which is going to tell us a bit more about what it means to use big size models when it comes to system benefits and the cost of solar energy. So Chen from DNV, the floor is yours, and feel free to share your presentation. And we can see.
Okay, thank you, Gerda. So hi, this is Chen from the DNV. I'm a part of the solar technology due diligence team in China at the DNV. Today I'm gonna talk to you analysis about LCOE regarding to the big modules. Like previous presentation introduced a lot of like the module itself. But when we, what does it mean in the field, and how does these large modules affect the design parameters? So we would like to know what difference were made when we put these larger modules in the systems, and what does the system will perform, and what does the cost? So in order to get these comparisons, so we set a same system size to compare, like a same DC and the AC capacity. So here we choose two different type of modules. One is 660 watt modules, and another one is 585 modules. This two type of module has fundamentally like different designs. First of all is the cell size. So as we can see, the 660 modules use 210 millimeters cells. And so that will make the 660 watt modules has like a large wider width. And you can see that the 660 watt modules has a low voltage and a higher current, as mentioned in the clause. So we can have more module per string in our systems. So in order to keep the systems same size, so that will make our systems has less modules. And also for the trackers here in the simulations, we select we select the next trackers. So we select the next tracker not for any other complexity reasons. We just simply select it as an example. Because we have done lots of projects and we have a certain amount of data on them, so we select this one as our examples. So as we know, the 660 watt modules have large width. So in order we keep like 3 strings per trackers for the 2 cases, because regarding to the next tracker's data sheet, so the tracker can hold up to 70 to 90 modules per trackers. So for now, we don't know if it can hold for more modules, but I think in the future, the trackers manufacturers will design the the trackers more compatible for the large modules. But for now, we just keep like 3 string per trackers for the same situations. So that make like we have less tracker numbers in the systems regarding to the 6 and 60 watt modules. And here I want to point out is like we also keep the ground cover ratios. The GCR is seen in order to keep the shading and the bifacial effect is roughly same. So here we want to make sure that everything is the same, only the module is different, to see how the big modules can affect the systems. And next, I would like to talk more about the module considerations about in the systems. So regarding to the inverters, as Klaus mentioned before, that the 660 watt modules has a higher current, but for now the inverters the products is it's typically is 15 amps inputs. So I think the future, the manufacturers, the inverter manufacturers will develop the products to compatible with the large current modules. So, but for now, we want to make these simulations. So in the PVCs, we do not select the individual PPT inputs. So we disable these functions in order to run the system, run the simulations successfully. And regarding to the wire length, as we know, that when we have higher module ratings, we have less modules in the systems. So the DC cable length here, we get a huge decrease. And regarding to the AC labeling here, because we assume that we have string per trackers, so that makes our 660 module systems have longer tracker lengths. So that will make you connect to the inverter to the middle volt stations. The wire is shorter. So we also make some assumption here, as I mentioned before, we disable the individual MPPT inputs, and the tracker price of these two of the module was given by the NAS tracker based on the tracker dimension change. And the PAM file was given by the customer and did not verify by the third parties. And we run these numbers in the PVCs, and we also do some post calculations. And finally, we come up these results. Actually, we run this. We run in two places, one in Spain and one in the US. And we just take it as an example because we have a large marketing there. And finally, we come up the final energy outputs. You can see these two places, the GHR is similar, and they are pretty sunny days, sunny places in these two locations. And regarding to the losses tree, you can see that 60 watt modules has better low irradiance performance, and as well as the temperature performance. And regarding to the module quality, when we talk about module quality, it contains three parts. One is a nameplate bias, and another one is MPPT non-identities, and another one is the modeling errors. For here, I think is the 60 watt modules. The modeling error is a little bit larger, so that makes the module quality slightly lower. And in the DC side, because we said the 660 watt modules has higher current, so even though it has less DC wire, but the current in fact is double. So here they has much more DC losses, but for AC it's save a lot of energies here. But overall, regarding to the night,
1 minute left. Sorry.
Already, okay. But regarding to the energy outputs, so it's roughly same. So I'm just goes to the final LCOE analyze. So overall, you can see the LCOE result is the 60 watt modules performance well, but this number here is not absolute values because we made a lot of assumptions, and I think if we can find compatible inverters cabling, and other assumptions, the number will different. But overall, compared with the 585 modules, the 660-watt module has less tracker materials and less DC wear and AC wear. So overall, the LCOE is the decrease is coming from the EPC side. So I would like to maybe other manufacturers can give us more informations, like to make can make us to make this calculation more accuracy. So I think that's for my side. Thank you.
Thank you very much, Chen, and thank you to everyone, all our audience, for following this webinar all along the way. Thank you to our great speakers, Gonzalo, Eckhart, Klaus, and Chen, for walking us through those very valuable presentations, but also those impressive and exciting developments for the solar sector. To all of us listening, you will receive a recording of the full webinar in the next 24 hours. So don't worry, you will not miss anything. And you can, of course, follow up with our colleagues bilaterally. So with this, big thank you to everyone once again, and to the Trina team, which has been working relentlessly in the background to ensure the success of today's launch. And to all of you, we wish you a lovely day and look forward to working together to bring forward the European and global energy transition. Have a very nice day.
Thank you.